We're now ready for problem 3 of these test review problems, another law of sines and cosines problem. So in the problem, we're given side B is 5, side C is 7, angle B is 20 degrees. So therefore we're going to have to find angle A, angle C, and side A. Now this information, this is an angle side, and I see it's a matching, so I'm going to have to use law of sines, and there's a chance, we don't know, it could be 0 triangles, 1 triangle, or 2 triangle. So law of sines, I need to use sine of B over side B, and I need to couple it with C since I know side C. So I fill in angle B is 20 degrees, side B is 5. I don't know angle C, but I know that side C is 7. So I can now solve for the sine of C, and it's going to be 7 times the sine 20 degrees over 5. Grab your calculator, make sure you're in the degree mode. Sine of 20 degrees times 7 divided by 5, 0.479. So C is going to be the inverse sine of 0.479, which is going to be 28.61 degrees. So there's angle C. Now I can get angle A easily since I know angle B and angle C. So angle A is simply going to be 180 degrees minus angle B minus angle C. And you do all that on your calculator, and you get angle A to be 131.39 degrees. So to make this clear again, this is really my first triangle. There could be 2 triangles. Right now we're working on the first triangle. The last thing left is side A. So let's go ahead and use law of sines. I'll group B and A. So the sine of angle A over A, the sine of angle B over B. So I know angle A is 131.39 degrees over side A, which was what I'm trying to figure out. Angle B is 20 degrees. Side B is 5. So now, if I solve for A, it's going to be 5 times the sine of 131.39 degrees over the sine of 20 degrees. So make sure you're in the degree mode. Grab your calculator. 131.39 the sine divided by 20 the sine times 5. So it looks like 10.97 will be side A. So here is the first triangle information. Now we have to check to see if there is a second triangle. And the way you do it is you go back. When I started this problem, the very first thing I found was angle C. if there's a second triangle, I can automatically calculate what the new, let me explain this. The information we're given, I'll write it here. This is still going to be true for the second triangle. If there is a second triangle, what's going to change are angle A. A lot of times for the second triangle, the new information, I put a little tick mark to tell me this is the angle A of my second triangle. I'm going to have a new angle A. I'm going to have a new angle C, and then also a new side A. So back to this. First thing I'm going to do is I'm looking at my second triangle. First thing I calculated when I started this problem was angle C of my first triangle. This calculation will give me angle C of my second triangle. You simply take 180 degrees and you subtract the original or the first triangle angle C, right? My first triangle, this was angle C. If I want to get angle C for the second triangle, 180 minus, so 180 subtract 28.61, 151.39. Now I still don't know yet whether there is a second triangle. If there is, this is my new angle C. So now if I know angle B and angle C of my second triangle, I can now figure out angle A of my second triangle. It's just going to be 180 degrees minus angle B minus angle C. Now if this is a positive number, then that means I will in fact have a second triangle. And it turns out it's 8.61 degrees. Therefore, there will be a second triangle. So here's second triangle angle C, second triangle angle B. Last thing I have to figure out is the new side A. So I'll just do sine of A over side A, and oh, I rewrote this. Sorry, keep doing that. This is the new side A. I'll just do sine of B over B. So the sine of A of my second triangle is 8.61 degrees. I don't know the length of side A. I know for my second triangle, B is going to still be 20 degrees. And side B is still going to be 5. So now my new side A is going to be 5 times the sine of 8.61 degrees over the sine of 20 degrees. So grab your calculator. The sine of 8.61 divided by the sine of 20 times 5, 2.19. So for the first triangle, this is angle A, angle C, side A. For the second triangle, angle A, angle C, side A. So it turns out there actually are two triangles that are both solutions for this problem. All right. The next problem. So we have here another law of sines, law of cosines, problem 4. Actually, I realize this is sort of confusing sometimes. I'm going to rewrite this real quick. Don't really need to draw that triangle because here's what information you were given for problem 4. You were simply given A equals 3, B equals 8, and angle A equals 80 degrees. So therefore, what do we need to find? We need to find side B, or angle B, angle C, and side C. I'm not worried about drawing that triangle because it actually makes it a little more confusing. So here we go. What do we have? We have angle side side matching again. Angle side side matching, which means law of sines. Once again, I could have 0 triangles, 1 triangle, or 2 triangle. So the first step, we use law of sines. I'm going to use sine of A over side A equals sine of B over side B. I know 3 of these, so by using this, I can get angle B. So the sine of 80 degrees over side A is 3. The sine of angle B, I don't know, but I know side B is 8. So now I can solve for sine of B. It's 8 times the sine of 80 degrees over 3. Grab your calculator, make sure you're in the degree mode. 80 sine times 8 divided by 3 equals 2.626. So now angle B is going to be the inverse sine of 2.626. So when I do my inverse sine, look at what I get, error. Now, this could in fact be no triangles, but sometimes you might get an error if you made a math mistake. So I would highly encourage you, especially on the exam, to go back, make sure I didn't make any math errors, make sure I copied the problem correctly, which I did, and if I checked all this, it all checks out because actually I didn't make any mistakes and there is actually no triangle. So that can happen sometimes. The information you were given leads to no triangle. All right, there are 2 more law of sine cosine problems, which I will finish in the next video.